In this video, I want to look at the geometric distribution. A geometric distribution has independent Bernoulli trials performed until the occurrence of the first success. So when we start talking about a binomial distribution, we want to know how many successes we get out of n trials. For a hypergeometric distribution, we then get rid of the independent, and for geometric, we still have independent, but this time we're just going to keep performing our experiment until we get our first success. In this case, our random variable x is the number of trials up to and including the first success. And the probability of success on each independent trial is going to be p. So let's figure out the PMF, the probability mass function, for a geometric distribution. The probability that our random variable is equal to x is 1 minus p to the x minus 1 times p. So we have x minus 1 failures, and then we have 1 success, since our first success is on the very last attempt. So we count up the number of failures we need, and then our 1 success. The CDF is then given by capital F of x equal to 1 minus p to the x power. For a geometric distribution, we have that the expected value is equal to 1 over p, where p is our probability of success. And the variance, 1 minus p over p squared. So let's look at some examples of this. If your probability of success is 0.7, what is the probability you meet an independent voter on your third try? So I want to know the probability that x is equal to 3. So what this means is the first person is not an independent voter. So there's a chance, if 0.7 is our chance of getting an independent voter, 0.3 would be the chance of not getting an independent voter. The second one is not independent, but the third one is. And this works out to be 0.063. Alternatively, we could have used the formula. We would have 1 minus p to the x minus 1, so 3 minus 1, times p. And we can see that this works out to be 0.3 squared times 0.7, which is exactly the same thing we got in the first case. Let's suppose we have a representative from the NFL's marketing division who randomly selects people on a random street in Kansas City, Kansas, until he finds a person who attended the last home football game. We're going to let p, which is the probability that he succeeds in finding such a person, equal 0.2, and x is going to denote the total number of people he selects until he finds the first success. So it's the probability he must select 4 people before he finds one who attended the last home game. So we want to know the probability that x is equal to 4. So the formula says 1 minus 0.2 to the x minus 1, so 4 minus 1, times p. In other words, 0.8 cubed times 0.2, which gives me 0.1024. So this would be the probability that he must speak to 4 people. A follow-up question, what is the probability he must select more than 6 people before he finds one who attended the last home game? We want the probability that x is greater than 6. So we would take the probability of 7 plus the probability of 8 plus the probability of 9, and this would go on forever, which we can see is impossible. So this is not how we want to do it. Instead, we're going to use the idea of complements. 1 minus what he doesn't want. He doesn't want it to be the first person, or the second, the third, the fourth, the fifth, or the 6th, and since this is what we don't want, we need to make sure we do 1 minus this value. So we have 1 minus. Since our probability of success is 0.2, this would be 0.2. 0.8 times 0.2, 0.8 squared times 0.2, 0.8 cubed times 0.2, 0.8 to the fourth times 0.2, and then finally 0.8 to the fifth times 0.2. And if we work this out, we get roughly 0.262. So the probability he must select more than 6 people would be 0.262. Finally, what is the expected value and variance of this situation? We know that the probability of success is 0.2, so the expected value is 1 over p, or 1 over 0.2, which would be 5. So he should expect, on average, to have to speak to 5 people. For my variance, we have 1 minus p over p squared. So 0.8 divided by 0.04, which is 20. So the variance here would be 20.